In this video together, we're going to do a protective device coordination study over a practical project that I've done before. And this project was about adding two 250 horsepower pump and connecting it to the existing load center 15 in this case. And what I'm gonna show you guys is what are the settings for each breaker and how do we coordinate each of these breakers so that the sequence of operation corresponding to each of them would be in a right order, so that if a fault happens downstream, we're gonna see the sequence of operation one by one from downstream to the upstream buses and upstream branches. So now I'm gonna open this project. For the sake of simplicity, what I've done is that I only cut the load center 15 branch from the power grid all the way to the loads and put it inside this new project for you to only have the picture of this, the scope of work in this practical example. So as you can see, we have two 250 horsepower pumps connected to the upstream bus, which is our load center 15 bus, and in between the pump and the bus we're gonna have two VFDs. Upstream of the VFD we're gonna have two circuit breakers, 400 amp circuit breakers, and each VFD has its own molded case 400 amp circuit breaker itself. So what I'm gonna do is that I'm gonna open one of the breakers for the pump number 2, CB pump XX2, and I'm gonna switch over the rating to see the rating of this breaker. So as you can see, the size or the frame size of this breaker is 800 amps. The continuous amp or the size of the breaker and the trip of this breaker would be set on 400 amps, and it's rated for 600 volt, and the test power factor is 20, and the interrupting current is 65 kiloamps, and so on and so forth. So what we did, we chose from the library, as you remember, we chose the solid state trip breaker from General Electric brand that can support the 800 amp frame breaker with the setting of 400 amp trip. So what we're gonna go and do next is that we're gonna switch over trip device. In this window we can see this actual setting of the solid state breaker that we already picked. So it has the type of the breaker, of course, is solid state trip. The brand or manufacturer is General Electric. Its sensor is set on 400 amp. Each phase, the LT pickup or long time pickup is when the breaker picks up, and it's set on 400 amps, and the band is set to a minimum for the accuracy. So, and the short time pickup is 4 times the full capacity of the full trip of the circuit breaker, which is 4 times 400, and it's 1600 amps. And it's also set to minimum. For the instantaneous amount of fault current that this breaker can handle is set to 12 times of its rated amp, which is 4800 amps. Let's click on OK. So what has been done here is, since these two branches for each 250 horsepower pumps have the same characteristics, so the breakers for each branch is set with the same exact settings. For the feeder breakers and the VFD breakers, we're gonna have the same settings, so we can just put the same breakers and settings for each of these breakers. And what we also have upstream here is a solid state trip relay which controls the upstream high voltage breaker, which I'm going to talk about the relay and the current transformers in my advanced ETAP course. But to give you a quick information of what this solid state trip relay does is that it basically, using the current transformer, it will detect the fault, and once it detects it, it's going to send a signal out to the upstream CBDB1 4CH1, and it's going to disconnect the line. And so now again, to get a quick idea about how this solid state trip relay works, let's double click on this relay and switch over input. What it does, as you can see, it is watching the current transformer CTDB1 3CH2, and which the primary side is set to 600 amp, and the secondary side is set to the 500 amp. And again, let's go back and double click on the current transformer. What you can see here on the rating tab is the ratio of the primary and secondary of the current transformer, which is set to 600 to 5, and the ratio is 605. Now let's click on cancel, and let's go back to the solid state trip relay. And again, let's go to the input, and you can see for the phase and the ground, it is set for the input of this relay. We have the current transformer, and on the output tab, we can see that it has connected, and it sends out the signal to the device called HVCB, which is the high voltage circuit breaker. And you have the tag ID of this breaker, CBDB1 4CH2-1, which is the upstream high voltage breaker, and the action is open. So when it detects the fault, it will send the signal and opens the breaker. And again, I'm going to talk about this solid state trip relay in more detail in my advanced ETAP course. So what I'm going to do now in this step, I'm going to click on fault insertion icon on the right hand toolbar, and as you can see, the color of the arc flash is black the moment it goes on the bus, or where is the destination point for the fault insertion, where is the point that we want to put our fault, it turns to red color. So now I'm going to put our fault on the bus upstream or of VFD for the second branch. And now you can see the sequence of operation for this branch all the way up to the third level, which is our high voltage circuit breaker. Now let's together create a time current curve, and using this curve, let's talk about how by putting a fault somewhere downstream our system, we're going to get a correct sequence of operation for each of the circuit breakers in that branch. So what I'm going to do, I'm going to select the right branch from the high voltage circuit breaker all the way down to the bus upstream, the VFD. But before creating the time current curve, I'm going to put a fault and run the simulation again. And while it is being run, I'm going to select the right branch again from the high voltage breaker all the way down to the bus upstream, the VFD. And this time I'm going to create a star view by clicking on its icon on the toolbar. Now, as you remember, we're going to get the time current curve corresponding to our circuit breakers And in order to have a better image, I'm gonna move the one line part on the lower left corner. As you can see, I'm gonna select it and move it somewhere on the right side of the screen here, and I'm gonna zoom it in to make it more legible, maybe a little bit more. Now what I'm gonna do, because the font is a little bit big, as you can see, I'm gonna right click on this tag and label and go to the plot option, and I'm gonna click on the font for the label setting and change the size to 6, and I'm gonna click on OK. So now we have these settings in a better shape. Again, I'm gonna do the same thing for the other labels. Size 6 is the appropriate size. This is a good practice in case you wanted to change the font style to whatever font that you would like. But for the sake of this project, I'm gonna just keep it by changing only the font size. Okay, now that we changed the font sizes and made it smaller, let's turn on the grid lines to have a better understanding.